Good morning. Second day of KubeCon. How's it going so far? Cool. All right, so just to introduce myself, my name is Sugu. I am the co-creator of Vitess, which I started in 2010 at YouTube to solve its scalability problems. And over the years, the community took interest in Vitess. So in 2018, we ended up donating Vitess to the CNCF. And around the same time, I left YouTube to start PlanetScale, mainly to provide dedicated support for this project that was gaining traction and community excitement. Deepthi here is a software engineer at PlanetScale. She has quickly ramped up. She is now one of the top contributors of Vitess, and also has the elite role of being a maintainer. As you know, one does not simply become a Vitess maintainer. So without further ado, Deepthi is going to give you a good intro about Vitess, and then I'll come back and give you a demo that will hopefully blow your minds. All right, here you go.
Hello, everyone. Vitess is a sharding middleware for MySQL. It sits between the application layer and the database, and it's massively scalable. There is actually no known limit to how big a Vitess deployment can be, which means that we haven't still pushed it to its limits. It's highly available. There are several deployments which are running with 5 nines of availability right now. Vitess is also cloud native, and as we go along the talk, we'll explore what makes it cloud native. These are some stats on Vitess. What's interesting to us about the stats is not how many people have adopted Vitess, but what are the big names that have adopted Vitess. There is Slack, which is about 25% migrated to Vitess, and they are on track to move 100%. There's JD.com, which is a huge Chinese e-commerce company, and they are running what is probably the largest known deployment of Vitess with over 10,000 individual MySQL instances. Square Cash app runs completely on Vitess. Square has actually published an interesting series of blog posts on their usage of Vitess, especially emphasizing the way they have sharded using Vitess, and we'll link to that at the end of the talk. Pinterest is running all of their advertising campaign management on Vitess as well. This was a tweet by Jack Dorsey, and this came out just before KubeCon Seattle in December. And our friends at Square like to joke that they actually overtook YouTube, which was where Vitess was founded. This is what the community for Vitess looks like, and these are just the companies that have given us permission to use their logos. There are a lot more adopters of Vitess which are not listed here. Many of these companies have engineers that have contributed significantly to Vitess, and there is a very vibrant group of people that are active in the community. Let's talk a little bit now about what makes Vitess cloud native. Vitess actually predates Kubernetes. It was built to run on Borg, and it was Kubernetes compliant. It could run on Kubernetes before the 1.0 release of Kubernetes. I guess Kelsey Hightower's tweets are going to be quite popular at this conference. We are not the only ones using them. And he's absolutely right when he says that running stateful workloads on Kubernetes is not a decision to be taken lightly. It requires a lot of work to get that working. And we'll see what we'll see what has been done in Vitess to actually make stateful workloads a possibility in Kubernetes. This is what the Vitess architecture looks like. The main thing to notice here is that there is a clear separation between the application layer and the database layer, and the interface between the two is what we call VT gate. This is a gateway through which applications connect to Vitess. Applications can connect to Vitess as if it is a single database, because Vitess speaks the MySQL protocol, and VT-Gate exposes an endpoint to which applications can connect using the MySQL protocol. The other components that are of interest are VT Tablet. VT Tablet sits right next to a MySQL and takes over the management of the MySQL instance. Then there's also the VT-CTLD, which is the control plane that can be used for management functions. So given this architecture, how does it enable us to run a stateful workload in Kubernetes? Typically, in a Vitess deployment, you will be running MySQL or the variants, Maria, Percona, which we also support. You will be running them in a master replica configuration. So you have one master and two or more replicas which are replicating from the master. And there are two problems that have to be solved in order for this to work correctly in a Kubernetes deployment. There's the availability. You never want your database to become unavailable, and you never want to lose the data. How does Vitess provide availability? Let's say you were just running MySQL without Kubernetes, and you have a master replica configuration. If the master goes down, it requires manual intervention to either bring it back up or to make one of the existing replicas a master. And the same thing applies in Kubernetes. You might be running your MySQL instances as a stateful set in order to provide high availability, but Kubernetes is not aware of the master-replica relationships, and if the master goes down, it will take a certain amount of time before it comes back up. And it is not transparent to the applications. Whereas what you get with Vitess is, because you have VT-Gate, which is a stateless proxy that sits between the applications and the database, and which knows about the master-replica relationship, any change to a master is transparent to the applications. And Vitess has the management functions to fail over if a master goes down, and to make one of the replicas the master. And the old master can come back up as a replica and connect and discover and connect to the new master and become a replica. The other problem we had to solve is that of not losing the data, obviously. So let's say you were just running it with a local volume or host path in Kubernetes, and a pod goes down. With local storage, you do lose the data. What we do in Vitess is that we have the ability to take backups and restore from backups, and you back up regularly. So if a master goes down, you fail over to a replica, and you bring the old master back up restore it from a backup, which might be a little bit behind the replica in terms of what transactions have been applied to it, but it will connect to the new master and then catch up. So now you are back to your original configuration with a master and multiple replicas, and you haven't lost any data. So the key insight that enabled this is that in a cloud environment, you you have your data only if it's replicated to multiple places. How would one start with Vitess? Let's say you already have an existing application and a database. You could just plug Vitess in and put it in front of the database, between the application and the database. And without even sharding, even if scalability is not an issue, even if you are just starting out and your traffic is not a lot, your data size is not big, you still get a whole bunch of features with Vitess. As you start growing, or as you start migrating more traffic to Vitess, you might want to deploy more instances into Vitess in a replica configuration, and this gives you higher read scalability, and you also get availability because Vitess integrates with GitHub's orchestrator, and that can be used to fail over from a master to a replica in case of a master failure. As your traffic and or data size increases, you might discover that all of your data doesn't fit into one instance anymore, and now you have to start splitting it. And initially, you might want to actually split the data by table. So you want to move some of your tables into a different instance. And this can be done transparently to the application. The application never needs to know what is the physical database where the data resides. Everything is mediated through VT-Gate, and VT-Gate knows how to route queries to which database. And this concept of splitting tables across databases is what we call vertical sharding. Eventually, hopefully, you will reach a point where even with vertical sharding, some of your tables are so huge that either they don't fit into an optimally sized MySQL instance, or you start noticing performance degradation. And at that point, it's time to do what we call horizontal sharding. And horizontal sharding is really the core component of Vitess that gives you the near infinite scalability. And what happens in horizontal sharding is that the same table is split across multiple instances of the database, and the application doesn't need to know that. VT-Gate will route queries to the appropriate shard, and if necessary, it will actually do a scatter gather. It will route queries to all necessary shards and combine the results and then return them to the application. There is no fixed sharding key in Vitess. The sharding scheme is flexible. There are some built-in sharding schemes, but you can also create a custom sharding scheme and plug it into Vitess. You can also replicate your data across regions or availability zones, whether it's for disaster recovery or in order to provide the necessary availability across geographic regions. And Vitess supports that. Now it's time for the demo.
Cool. All right. Okay. So how many of you have used the Vitess sharding scheme or seen the Vitess resharding demo? Okay, one or two. Okay, then be ready to get your mind blown. So I'm going to go actually, the original, I gave a tutorial last KubeCon about the full sharding thing. Today I'm going to show you an improvement that we made to Vitess. So that's what I'm going to talk about. So this new feature is like totally bleeding edge. It's like about 90% done, which means that in the next 10 years, we'll get the other 10%. So So as Deepthi explained, there are basically two workflows that we have in Vitess. One is you do vertical sharding, where you move tables from one key space to a brand new one. And the other one is horizontal sharding, where you split a key space into multiple parts. But then people have come and asked me, hey, yeah, this is all great, but what if I've already sharded, and then there's one table in my unsharded key space, and I want to move it to my sharded key space? No, you can't do that. How about unsharded to unsharded? Sorry, no, can't do. How about sharded to unsharded? Why would you even want to do that, right? And my personal favorite is, I have sharded my database, but I chose the wrong key. So we call it the regret feature, because I regret sharding it this way, I want to do it the other way. So all these features are now possible in Vitess using VReplication. But we actually chose a different approach. Instead of building all these 10, 15 workflows that can possibly exist, what we have done is componentized the portions that we used for resharding and made it basically scriptable by just you as a person, so which is what I'm going to demo. But we actually went one step further. So this VReplication feature is not only usable for sharding, it's also usable for multiple other things that people haven't even thought of. So at the core, what VReplication does is it can materialize anything. Anything means a group of tables, because MySQL has only tables. Anywhere, which means that you can choose any source key space into any target key space, and even the target key space can be the source itself, if so you desire. And finally, anyway, this is the part where the coolest thing about this feature is, which is that anyway means that you can specify transformations, which means that I can say I want to replicate only these rows, or I want to replicate only these columns. I want to replicate these columns, but I want to apply the following transformation expression. And how do you specify it is what makes it powerful. You specify that just by giving a select statement, which is the representation of the table that you want to materialize, which is why we call it materialized views. And this select statement can be basically any SQL statement. It can even be aggregations. You can do sums and counts. And Vitess will materialize your table aggregated in your target key space, which means that there are many analytics workloads now that you can efficiently create views for and directly hit those tables. Unfortunately, I don't have time to show all those features. I am only going to show the part of VReplication that is going to help you create new resharding workflows as you desire. Okay? So this is the classic demo that we have. This tutorial exists in Vitess. If you go to the Vitess documentation, it walks you through this tutorial. This is an e-commerce application where there is a product and there are customers placing orders. You start with one database, the commerce database as product, customer, and order in this one database. And then you do vertical split, move customer and order into an unsharded customer database, and then you reshard the customer, which is what the tutorial does. Most people have gone through that tutorial. Nobody has seen a problem. And if you need help, you can also see my last KubeCon presentation about this. Today, what we are going to do is do this as one step. And not just as one step. We are not going to use any pre-existing workflows that Vitess has. We are just going to craft this with our own bare hands and make this resharding work. Okay. And so here's our starting point. There is the commerce database that has these 3 product, customer, and order table. Don't worry about those sequence tables. Those are not relevant for this demo. Assume that they help you generate IDs. And the magic is in the VT-gate. There is metadata in VT-gate. For VT-gate, we call it the V schema, or the Vitess schema, the sharding schema. And that basically says product, customer, and order are in the commerce database. So when the app server sends a query to VT-gate, VT-gate knows, oh, I'll send it to commerce because that's where those tables are. So the next step we are going to do is create our target key space pre-sharded. We are going to create a user database, user key space, which is sharded -80 and 80-. 8 is hexadecimal. It's right in the middle. So as soon as you create this key space and you create customer and order tables, it's called C order because order is a keyword in MySQL. It does not like it, so I put a C in front to stand for customer order. So you create these tables, and once you create them, VTGate is going to get confused because you say select star from customer. It says there are 2 customer tables. There's one in commerce and one in user. What do I do with it? So this is the first feature of resharding, which is called the routing rule, where if you see at the bottom, you see that I'm saying customer, if you see a query for customer, send it to commerce. And so which means that in this setup, we now have the user database, customer and order tables exist, but as far as the VTGate is concerned, no traffic goes there because they all go to commerce. The next step is the magic step, which is create a VReplication using select statements and basically say materialize customer and order, half of them to -80 and the other half to 80- using a Vitess sharding scheme. And all this is expressible as a SQL statement, and I will show you what that statement is. Nothing else changes. Rules are remaining the same, which means that app servers queries continue to go to commerce. Eventually, what VReplication is going to do is catch up on replication, and all the data in commerce is going to be present in user also for customer and order. And the last step is the cutover. It's actually a 3-step process. We go blacklist the source tables, which means that stop accepting writes, and then wait for, the second step is wait for VReplication to catch up. And after it has caught up, you tell VTGate, okay, now you can start sending writes to the new key space, which is basically an update of the routing rules. We'll say customer now goes to customer.customer, and order goes to customer.order. So this makes sense? Cool. So 3 steps. And the best part of it is you can craft your own resharding steps using just these 3 basic tools. I am now going to jump into the demo. And before jumping into the demo, Deepthi was nice enough to build me a Vitess cluster here using the PlanetScale operator. You can bring up Vitess using Helm charts. There are Helm charts. There is a Vitess operator that's in alpha in Vitess. And on the commercial side, right now, there's only the PlanetScale operator. I think there are some other people who may be working. I think Rancher Labs may be working on something. So here, you can now see that I have brought up. So what I've done is, in the interest of time, because pods take time to come up, I've brought up all the pods and key spaces, and I'm just going to show you the 3 steps, the last 3 steps that are involved in the sharding. So here is the commerce key space. It has actually all the 3 tables. But if you look at the customer key space, it is completely empty. It has nothing. I just created those shards. And if you look in VTGate, this is the V schema that I talked about. And you can see that in the key spaces, customer is not even listed here because it has nothing. And you can see that C order, product, and customer are here. Just ignore those auto increments for now. They are not relevant for this demo. So this basically means that if I send queries, they will all go to customer. So this is and we'll watch this V schema change as we progress forward in the demo. And at this point, there is, let me see if somebody, I did send the queries myself. Okay. So here is our awesome e-commerce app, awesome UI, but we all have to pretend. This is basically, you have to imagine if you want to create a product, you go here to the left and then enter your SKU. If you want customer, you just enter your name in there, and you can enter this order info. So this website is publicly available. You go to resharding.planetscalelabs.com, and you're allowed to spam it. Let's see if you can take it down. And while you spam it, I'm going to do the resharding, and we'll see if we lose any data or whether resharding falls apart. All right, so go ahead and start generating load. No load yet, okay. So while we do this, I'm going to show you my scripts, 303. Yeah, resharding.planetscalelabs.com. So here is my script number 1, which is going to do this step, which is this one, create those V schemas and the routing rules, set up the routing rules, right? So first I copy the schema from the source to the target, and you can see the routing rules. It says I'm going to say customer goes to commerce.customer, and order goes to commerce.order, and then I apply the V schema. So I'm going to run the script. The script has been run, and now if you go see the schema here, you can see that customer has appeared, but more importantly, at the top you see the routing rules, just as I explained. And now let's see what happens here. Oh, somebody actually has. So this has not changed because the queries are continuing to go to commerce. So if you look at the query plans, you can see that this select statement is still going to commerce. Basically, all your queries are going to commerce database. So VTGate shows you on the fly. You can look at VTGate, show me the queries you're executing and how you're executing them. So this is a debug query plans page. And so let's see if somebody has entered anything. Ooh, someone's spamming. Awesome. So the next step is do the VReplication part, which is, where is this? The next step here, the VReplication. So that is actually, it's a very simple script. I typed it myself. It's actually very hard. The reason why this script looks very complicated is because it is complicated. It is actually a bash script that has a SQL statement. Inside that SQL statement, there is a protobuf. And inside the protobuf, there is another SQL statement. So how do you represent that in bash? And more importantly, how do I create a command like this? Well, fear not, there is help. What I have is a program called VReplication.go. And what this does is allow you to just put your parameters in and run this program, and it will generate your command for you. So you can see the select statements here, select star from customer where the customer is in key range. So you basically specify your resharding workload using these select statements, and then go run this. And it generates this code. You just paste this into your script, and you're off to the races. So back to this. Let me run this. /304. It has run. And as you can see, nothing would change because this is basically an offline process. The original database is still accepting writes. And nothing has changed. OK, the last step, which is the cutover. So this is where everything will change. And we'll see what that is, 305. And this is actually, you can actually manually do this, but you have to do this very fast because you're going to stop writes on the source and then wait for replication to catch up and then enable writes on the target. So you want minimal downtime. So I wrote a quick script internally in Vitess. What I'm planning to do is actually make it available in a customizable way for anyone to use as a cutover. So if you run this command, 306, I believe, or is it 305? 305. Boom, it's over. We have cut over now to the new traffic. Let's see if site still works. OK, it works. And what's the proof that we have even cut over, right? I may be lying. So let's see what VTGate has to say about the plans. The select is now going to customer. It was going to commerce before, now it's going to customer. You can see that the customer queries are now going to customer, product query will continue to go to commerce and everything else. So we have now actually officially Cutover, which concludes the demo. The best part of this is you can use these scripts to reshard from anything to anything. There are actually a lot more workflows that you can do with this. You can actually, if you go to the Vitess documentation, click on documentation, scroll down here in advanced features, there's a VReplication operators guide. And here it talks about all the other things you can do. You can do materialized views, you can do real-time rollups, you can do backfilling of lookup indexes, schema deployment. There's a whole bunch of workflows that you can now implement and use within Vitess. So that concludes our demo. And if you have any questions. Yes? When I reshard the table, what do I have to do? Yes. Yes, yes, yeah. Correct. Correct. So the question is, when you do the resharding, do you require twice the storage? And the answer is yes. So while you're doing the resharding process, you will have to allocate space for your target key space. At that time, you pay for twice the storage. Typically, a resharding may take you, depending on your data size, it can take you a day or it can take you a week. So during that time, you pay for the added storage. But then after that, what you do is you go back and delete your old tables, and then you can shrink back your database to their original size. So once the resharding is complete, you should go back to the amount of resources you were previously using, more or less. Is that a lot of height? Overhead? Oh, a lot of writes, yes. The number of writes will also be increased because what is being returned to the source table is also going to be returned to the target table. So the number of writes is going to go up. So you need to provision both for space and write IOPS. Yes? So the question is how much downtime is involved in resharding? Practically zero, because the entire resharding process, as you saw, like when I was doing the demo, you were all spamming the website and it was still accepting writes. It's because the whole resharding process is actually offline. The only time when you would see downtime is during the cutover, which in this case happened instantly, but typically it happens in a few seconds. So for a resharding, essentially the downtime you see is 4 or 5 seconds maybe. And it's also extremely safe, which means that if halfway through the resharding fails, you can say, oh, let's go back to where we were. You can do that. After you have done the resharding, you say, I may change my mind. I may have to go back after a day, in which case you can reverse the VReplication and write what you write in the target back to the source. And then if you decide, you can actually switch back to your source also. So there's rollbacks both during the process and after the process. Yes? Well, I didn't understand. When you're doing the merge, when you're doing the shard merge, oh, yes. So the question is, when you're doing a shard merge, is it possible to have the same data on multiple shards? And in that case, your merge will fail. So it is your responsibility to make sure that the shards have distinct data. And there are actually indexes in Vitess that allow you to specify and enforce them if you so desire. You can, for example, if you make the primary index same as the primary key, then uniqueness is enforced. Or you can create a unique lookup index, which can enforce uniqueness of at least one of the columns in those rows, which ensures that the rows are all distinct, in which case the merge will succeed. Yes. The question is, how do you back up? Deepthi will answer the question.
We have two ways of doing backups. One is where we just copy all the files, and that requires downtime on whichever instance you are using to do the backup. So that's only allowed on replica type instances. You don't allow it on master unless it's an emergency situation. We also support Percona's extra backup, so you can do an online backup using extra backup.
She wrote that feature. The
Yes.
question is, was the demo running on Kubernetes? Yes, it was running. We were using the PlanetScale operator, Deepthi.
The demo is running on GKE,
GKE.
with the PlanetScale operator. We do have many people running in production on Kubernetes, and some of them are very large instances. And one of them, Stitch Labs, has been live in production since 2016.
2016. Probably the oldest stateful workload in the world. On Kubernetes, yes. Yes, you.
Hi.
So basically, if you have a sharding, it is very hard to do backup because you need consistency between all your instances in your shard. Yeah? And do you have some coordinator for backups which you can say, hey, do backup of this shard, of this shard, of this shard, in particular one point of time?
So we don't actually have a coordinated backup across shards. You can back up a specific instance, or you can back up a shard. But this logic of doing a coordinated backup across shards doesn't exist in Vitess today. I think we are out of time. I will be at the CNCF answer bar this afternoon at 1:30 if people would like to come by and ask questions. And we are also available after the talk to answer questions.
We also have our PlanetScale booth. And tomorrow, Jiten and Dan are going to show the HA features of Vitess. They are going to, I believe, play whack-a-mole with pods. So if you're interested, please attend.